Do you have your notes from yesterday? I think so, yes. We finished, oh no. Yeah, that's right, we finished, this is what I'm doing right now.
Okay.
It's right there. All right, this particular problem was about the sending suggestive images over text or posting them online. And it said there were like 20% of the population, teens, that did this. And the counselor at the high school thinks that probably more at her high school does that, right? All right, so there was your ho and there was your ha. This is the end of the problem that we finished yesterday. P-value low, reject the ho, right? So my p-value is low. Hey, shh, concentrate, y'all. If your p-value is low, here is how you decide what your sentence is. P-value low, reject the ho. So you always write about the ha every single time, never the ho. And so if we are circling the ha, that means we are going with the ha. We have enough evidence for it. We have enough evidence to conclude that the proportion of teens, blah, 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 is greater than 20. You write about the ha every time. All right, so next problem. This is about smoking, and it's on the next page. According to the CDC, Centers for Disease Control website, 50% of high school students have never smoked a cigarette, which means 50% have, right? This Tayon wonders whether this national result holds true at his large urban high school. For his stats class project, Tayon surveys a simple random sample of 150 students from his school. 90 say they have never smoked. All right, when you are looking at a problem, hey, let's move past that. When you're looking at the problem, when it says give appropriate evidence to support your answer, y'all, the appropriate evidence is state, plan, do, conclude. You have to do all four. You can't just do the do part. You got to do all of it. So we need to know the p hat, the p-value. They're all three different things, right? Anybody see anything in there?
150 and 90. 90 out of 150.
Okay, so p hat is what y'all are telling me because y'all are saying the same thing. 90 out of 150, which happens to be 60%, right? What about the p? That was p hat. 0.5. P is for the whole population. So the whole population of America has 50% who have never smoked a cigarette, right? So there's a p, there's a p hat. There is also an alpha. Did it tell you the alpha in the problem? If they do not tell you the alpha, it is 0.05 every time. All right, so on your thing, you've got, if they do not give you one, you use 0.05. We've got a p hat. I have not filled in my ho and my ha yet. It is. But a lot of times people will just write, okay, 0.5 and then 0.5. Is that how you write it? Good. P equals 0.5. Okay, good question. The ha has to be a greater than or a less than, or it could be just a not equal to. In this particular problem, I know y'all are writing that sentence, but just a second. It never said that Tayon thinks his high school has more or less. He just wonders if it's the same, doesn't he? So not equal to. It never gave us a greater than or less than. It's just a not equal to. Now, when you're doing your state, if you do not define your parameter, you will not get full credit. P could be anything. P could be the proportion of people at his school that have brown hair. But that's not what the problem was about, right? It's the proportion of people who have never smoked a cigarette. So you have to put find the parameter part on there. Do you know the majority of this class is explain yourself? There's not a whole lot of math. Like there's some math, but it's dividing or multiplying, right? It's mainly can you explain the problem? That's why it's sort of a math class and sort of not. All right, in the plan part. First of all, what type of test are we doing? Z or T?
Z.
Good. It is a one sample because Tayon only took one sample, didn't he? No, we will do two sample. One sample Z test. One sample Z test. Previously on the other test, we did one sample Z interval. But you're not doing a confidence interval right now. You're doing a test. All right, check your conditions. We have checked conditions numerous times. Let's see if you can check them on your own. Can you? Mm-hmm. I will. Random, independent, normal, right? No, she's right. So here is your problem about non-smokers. See if you can do random, independent, normal on your own. Look at that. SRS of 150 students. Definitely random, right? Do not just put SRS check. You got to say of what. It's not a simple random sample of pineapples. It does not say, but we can assume because it is a large high school. Homewood is actually considered a medium high school. We have 1,200 students. And I don't know, Vestavia has like 1,800, 1,600 or something like that. Do what? Yeah, is it 18? Okay. Ooh, wow. Mm-hmm. How about you do random independent normal? What is with the candy? I know. Angel Leaf. Random, independent, normal. It's really okay. I don't care. Is what? It is. How many people were in his survey? That's what you're always wanting to know. You should be doing random, independent, normal right now. If you get stuck, ask a friend sitting next to you. I don't know where that came from. I have no idea. People just draw on my board all the time. I don't know. I'm assuming you have gotten this far. No, just at the school is fine. What? Well, if we can't assume that, then we can't do the problem. So you always have to assume there are more than however many. 10 times whatever your n is. Uh-huh. Yeah, that's fine. No, you don't. Very good. And that is not a stupid question. Yes, it is the 0.5. Mm-hmm. All right, I'm going to assume you are done. because many people are talking, so I'm guessing you're done. All right, right here. Hey, I need you to concentrate. Listen. Right here, you have to use the P, which is 0.50. Do not use P hat. That's not what goes into that place right there. If you use P hat, you're going to get a number that's pretty close, because 0.50 and 0.60 are not that far away, but it'll be wrong. So you won't get credit for that. Also, when you do this part and this part, that's perfect, but you do still have to write that it's approximately normal. So make sure you write that out to the side. That's important also. If it is approximately normal, then we can draw a bell curve, and that's what we're about to do, is draw a bell curve. All right, your formula that you're about to use is right here on the formula sheet. Not right there, sorry. Here's your formula sheet. Right there. At the top of the page, we've used both of those formulas, haven't we? We used that one for the confidence interval last test. This is the one you're using this time, standardized test statistic. Now, your test statistic is either a Z or a T. On this problem, what is it? It's a Z. Guys? No. Sorry.
Someone said ask your teacher. They always say that.
No. Maybe elementary school. All right. Z or T. So this is going to be a Z-score this time. And I know I wrote that. I typed it on your paper. But you got to know what your statistic is, what your parameter is, and also know that if you're doing a standard deviation, you're using one of those. Well, I'm obviously using this one this time, right? All right. So what is my statistic? What is my parameter? Go back to the top where you have the state. Which one of those was the sample proportion?
0.6.
Correct. That is your statistic. That's your sample proportion. All right. So your statistic is your sample. Think of SS, statistic sample, right? Parameter is the whole population, P and P, parameter population. And the whole population proportion was 0.5, I think. And then your standard deviation came from that formula that I just showed you with the square root, all that. So you should have 0.60 minus 0.50 over that square root thingy. Do you need a calculator?
You said we need the bottom number.
You do. You do. Yeah, don't do it all at one time. Do it separately. Would anybody like to give me something in return? Now, what you just found is a Z-score. That's a Z-score. So that is where you would put your line on the bell curve. You notice there are two shaded areas on this bell curve, and I'll tell you why in just a second. Yeah. Sort of, except that we just didn't know. We don't know if it's a less than problem or a greater than problem, so we have to do both.
So it is less than. So it's like plus or minus 2.4.
It's a plus equal.
Yeah, no. She's saying 2.45 positive and 2.45 negative is what she's saying, right?
It's an order.
Yeah, that's what she was saying. All right. First of all, when you draw your bell curve,
She's wrong.
hush. In the middle, what goes in the middle? The P. The whole population, because this is a bell curve for the whole population. And then we're changing it to a bell curve for the sample, which is what you just did when you did that part. All right, so 0.50. The standard deviation, we go out by 0.04 every time. And unfortunately, because you have two sides, you have to write both sides. I think I rounded. I did round. That's your Z-score. All right, so you know how to get this number in the middle. You know how to do your standard deviations on each side, right? That's from that up there. It's all these little bitty pieces that build on each other. Now, it is a two-tailed bell curve because of that whole not equal symbol at the top. We don't know if it's a less than, and we don't know if it's a greater than, so we're going to do both of them. We're first trying to find the probability that it's greater than 60%. All right, there were kind of two numbers in this problem. There was a 60 and there was a 50, right? 50 was used in the middle. You draw your line at 60%. That's where you draw the line. It's also at 2.45, which is your z-score. So that line is at the same place. If I'm drawing one there, I'm drawing one over here at negative 2.45. One's at positive 2.45, one's at negative 2.45. Now you got to grab your calculator. Do y'all know we always do an x and a z and an a, right? X is, where did you draw your line? Well, yes, but it was 60%, wasn't it? Your z, normally on a z we would do x minus mean over standard deviation, but you've already done it. It was 2.45. All right, now, calculator. Here are your options. Am I going to do a normal CDF? Good. Not an inverse normal. That's only when you know your area. I don't know my area, so I'm going to do a normal CDF. My lower on the right-hand side is 2.45, and my upper is 1,000, right? Okay, and I don't change anything else, and I hit paste. Did y'all get that?
Wait, why wouldn't you do,
The lower one?
yeah.
I'll show you, but do the upper one first. So hopefully you got 007 for your area, right? Now what you just found was this side, but I've got two of them. That side, and I also have this side. You just double it.
Why don't you put it like,
Area in the middle, but we're not trying to find that probability. We're finding the probability that it is greater than 60 at his high school or less than 60. They are the same. That's why we're having two of them. This is the area of that one, 0071. 0071 down here also, so we have to double them. You're right, they are the same. So my p-value is actually not 0071, it's two of them. That's your probability of getting a sample of 60%, basically. It's a 1.4% probability that you would get a sample like that in that high school. Now, what do you do with that? Yes, something. You do write a sentence, but you got to compare it first. You got to compare it to your alpha. You are correct. Is my p-value low? Reject the ho, right? This was my ho, and this was my ha. It was p equals 0.50, and p was not equal to 0.50, right? Reject the ho. Is there enough evidence to conclude my ha?
yes.
Yes. So we reject the ho. There is enough evidence to conclude now, so you can't see mine. I want you to think about it. There is enough evidence to conclude that the proportion of students who say, well, what were they saying? That they've never smoked a cigarette, right? Is not 50%. Because is not, you're going with whatever the ha tells you. There is enough evidence to say that that proportion is not 50%. We never said whether we thought it was more than 50 or less than 50. Although in his sample it was more than 50, wasn't it? But that's not really what we're saying. We just are saying that it's not 50. Everything starts with the ho and the ha, and it builds off those. And so if one little part is wrong, it's going to mess up the whole rest of the problem. Now, this is how the way the grading is done by me and by the College Board. If you mess up your ho and your ha, you will definitely get points off for that. But if you follow it and do the right thing based off of the wrong ho and ha, you'll still get the credit down here at the bottom of the problem. Yeah, it is good. Because otherwise it messes up literally the whole rest of the problem. All right, go back and look at that problem. All the way from the state, and then the plan, and then the do, and then conclude. See if there's anything on there that you don't understand. Many times y'all are just copying and you don't really know what you're doing.
Is there always going to be enough evidence to conclude whatever?
There either is enough evidence or there is not enough evidence.
So when there's not enough evidence, that's when the p-value is higher.
Yeah, good. All right, next problem. Work stress. Are y'all stressed at work?
No.
Your work is kind of school. I guess y'all have jobs too, right? Yeah. 75% of people are stressed at work, apparently. Oh, restaurant. In the restaurant employee, yeah. All right, so this next problem. 75% of people that work in the restaurant industry are stressed at work, and work stress has a negative impact on their personal life. It's really sad. 75% is a big percent. Managers of a large restaurant chain wonder whether this holds true for their employees, so they did a random sample of 100 employees and found that 68% answered yes. So only 68% of their employees. Is this a good reason to think that the proportion of all employees in this chain would say yes differs from the national proportion? This right here is important. It just said differs from the other proportion. It didn't say is it greater than that one or is it less than that one. It just is different, right? So that's how you know you're going to be doing a not equal to problem. So let's go ahead and decide what all we have. We have a p, we have a p hat, we have an alpha value, which they didn't tell us. What are all these things? Say it again. I heard. All right, 0.68 is your p hat. 68 out of 100, right? Good. Y'all are getting very good at picking out the things. Good. They never told you an alpha value, so it is 0.05. All three of those things need to be in your state part.
Will it ever say it? Like, will it
Sometimes it does, and
it'll
it
say
did.
Like, how is it?
It did. It said alpha equals. It was a couple of problems ago.
So it's like
Mm-hmm.
okay.
And it'll do that when it's kind of weird, like 10% or, yeah. Okay, we need a ho and a ha, right? So we have a p-value, p hat. We have an alpha level. We have a p, which is 0.75. What goes in my ho and my ha?
How is p equals 0.75?
Awesome.
How is p is not?
Awesome. Make sure you define your parameter. P is the proportion of employees who say work stress had a negative impact. If you don't tell what it is, P could be the proportion of people who are late to their job. I mean, and that's not what the problem was asking. I think we have a lot of teachers that are late to their job.
You'll have to be on time, like if you don't have a class
No, you
first
don't.
period. Like if you don't have a class first period.
No, you still have to, yeah. Now, does anybody really check? No. But you're supposed to.
Do you have a first period?
I do, yeah. I'm usually rolling in here about the time y'all, like, bell rings.
I wish that. Because you take kids.
Uh-huh. I cannot drop them off till 7:30.
Miss Rage would like
It's hard.
leave her children in the street.
I know, she does. She does.
Like, she told us that.
Yeah, she really does. Leave them in the street. No joke.
I would have gotten mad at my mom.
Okay, try to do the plan all by yourself. Flip back to the previous problem if you need to, but try to do the plan part all by yourself. But just make sure basically you've got what all of that. Did you write this is approximately normal? Okay, good. Don't just put the n times p and n times 1 minus p. Make sure you actually say that it's normal. Oh, yeah. You mean instead of doing approximately? Yeah, that's fine. All right, the do part. Some of you have looked back at the previous problem. You've already started it, which is fine. On the do, statistic parameter. And since we've already talked about it, y'all know the statistic was your p hat. Parameter is your p. My statistic is, I don't remember. What was the p hat in this problem? Thank you. And then 75 was the whole population parameter. Is it okay if I get a negative? Absolutely. That just means you're on the left-hand side of the bell curve. This is a z-score. That is what you are finding. Draw your bell curve when you finish this. It does. Since this is a not equal to problem, you should have them on both sides. And the whole point in drawing the bell curve is to show that you know what's going on. You're not just typing random things into your calculator and maybe you hit on something and it works. You got to show that you understand that these are probabilities that we're doing from the area under the bell curve. All right, 75 is in the middle. You draw your line at that other number, 68%, which in this case happens to be on the left-hand side. Ooh.
We just want to put the standard deviation numbers and use the standard deviation as drawer.
That's fine.
We don't have to put those
Uh,
specific numbers.
You mean like, what are you saying? You're going to put,
Like I could just use 1.62 and then use 0 to 3 instead of all of those numbers.
oh, these, you can use 1, 2, and 3?
Yeah.
Oh, yeah, that's fine. Yes.
So I don't have to
No.
put those
No,
0.75.
it's okay. I would go ahead and put, actually, I'd put 0.75 in the middle just to show, yeah, you did, that you know that that's supposed to be the middle of the bell curve. Yeah. So I'm looking for my area at 68%. My z-score you already found was 1.62. Have you put it in the calculator yet? Anyone? It doesn't matter which side you put in the calculator. I'm just used to doing the positive one. So I always put in like 1.62 to infinity. Put it in the calculator, make sure you know what's going on. And then we're going to double it. Whatever you get is only one side. Did you get Z1052? Awesome. If you do one of the sides, you would get 0.526, but you have to times it by 2 because there are two sides. And then compare it to your alpha. Let's see if you can write the sentence, and then we'll be done for today. My p-value low? I don't think so. That's right. All right, so you failed to reject. Let me go back to the hoe. Oh, there it is. Right. If we fail to reject, that means we're accepting that one. There is not enough evidence to conclude. Yeah. We fail to reject Toe. There is not enough evidence to conclude that the proportion of employees who say work stress has a negative impact is not 75%. That sentence is weird because you have a not and a not. But just right here, write whatever the ha actually is saying. We're going to stop there. I know you have another page left, but we don't really have time. Let me come back to this in just a second. Look at your calendar. You are only doing number 49 tonight, not these two. Only 49.